In our previous video, we introduced measurement scales, nominal, ordinal, interval, and ratio. Recall that nominal are categories, so we need to make sure we have all the possible categories, so it is collectively exhaustive, and that it's mutually exclusive. So if we're looking at nominal data, you fall into one category but not another, so you can only be in one. Ordinal data is ranking, so it is mutually exclusive, collectively exhaustive, but adds that transitive property of something being better than something else. So here, those numbers indicate to us there is that priority and then a lesser priority. In comparison, interval data is mutually exclusive and collectively exhaustive. It has that transitive property where there is that the numbers do mean something in terms of the numbers themselves, but it adds in the fact that the difference between the numbers has meaning. So if something is 5 points higher, so if we're comparing 0 to 5, then the one that has the 5 is 5 better than the one that has 0, and the one that is 10 is 5 points better than the one that is 5. So that difference has a meaning as well. And then we have ratio. Ratio is mutually exclusive, collectively exhaustive, has that transitive property where there is a priority to it, has that interval where differences have meaning, but in this case with ratio, that 0 also is important because it means the absence of a measurement completely, whereas in interval data, it doesn't. So for example, nominal categories, are you a buyer or not a buyer? Are you a Swiftie or not? We could look at what groups you belong to, how you classify yourself. And in ordinal, we would look at preferences. So when we get to attitude scales are ordinal in nature because you strongly agree or strongly disagree with statements. Something makes you very happy or very angry. So there we have that ranking to it. So any type of rating system, what is the best, what is the worst, that's going to be ordinal. Intervals, we could look at your level of knowledge, your temperature, and then with ratio, anything that's a measurement, things like height and age, where when you have 0, it means you don't exist. When we are analyzing this type of data, when it comes to nominal data, we will look at frequencies and percentages. In our previous video, we showed how to do that in Excel. And you can also find the mode with nominal data. So what is the category that most people belong to? So we looked at Swifties. Let's go back. And we can see that the category that most people belong to is that, yes, they were a Swiftie. So the mode, the most frequent response, can be found with nominal data. Ordinal uses median, mode, and range. And in our previous video, we looked at how to calculate median, mode, and range. So we looked at 4 different rankings for what burger joints you like the best, what was the ranking. So here on a 1 to 5 scale, where half the people ranked above and half the people ranked below. So Five Guys was 2.5, half ranked it above number higher than 2.5 and half less than 2.5. The mode is the most common. So here, Five Guys, the most common ranking here was 3. And then the range gave us the measure of variability. How much difference are there in the rankings or responses? And so with Five Guys, we saw that the differences here were only 2 apart on the 5 scale, whereas with McDonald's, there was a difference of 4. So a lot more variability in the ranking that people gave it. Okay, so median, mode, and range is what we use for ordinal data. For interval and ratio data, we use median. So what point is half above and half below? And we use the mean. So what is the average response? And then standard deviation helps us measure how far on average we are from that average. So we're looking again here at variability, but this is assuming that there's a bit of clumping. And so we're looking for that measure of central tendency of the average, and then typically how far are you away from there. Okay. Now, when it comes to ratio data, there are some special calculations, one being the geometric mean. So let's look at how the geometric mean works. When we have data like inflation rates, so it's a percentage change or a growth rate or a rate of return. So we're looking at a percentage change, new minus old divided by old times 100. Then what we would do, instead of calculating the average, we could calculate the geometric mean. So the geometric mean doesn't work with negatives. And the reason, we're looking at change over time. So with inflation, for example, we mostly have an increase in prices. So we could use the geo mean. And the reason you would use a geo mean instead of an average is that when we are looking at percentage change, we're looking at percentage change over time. And we want to put essentially a greater weight on more recent information. So the geometric mean is going to take that into consideration. So here we have inflation from 1980 to 2015. How much prices have increased? The average increase from year to year. So we'd take all of these numbers and divide by, and here, what do we have? 35 different numbers here. We find that the average increase in price from year to year is 3.3%. The geo mean, so we type in geo if we're in Excel. Okay. And just to be fair, we'll put it in percentage too. So notice how here this number is smaller. And that's because we have high inflation in the 80s, but as we move towards 2015, we get a lot lower percentages. So we are looking at, in terms of that expected inflation, looking at the past, if we're going at growth going forward, maybe it's going to be more close to 2.38. So we use the geometric mean when we're looking at growth rates, but remember the geo mean doesn't work if there are negative numbers. So if you were looking at negative growth, positive growth, negative growth, positive growth, then the average, takes what's above and what's below, kind of cancel each other out. That'll give you your average. The geo mean says, well, this percentage growth is going to build on that percentage growth, and it's going to have, it's not just that each year starts from zero, it's that the growth in the previous year adds to the growth from the year before. They're all positive numbers. And so it's going to then kind of take into consideration more that relationship between those years. So you might use the geo mean instead of the average if you are dealing with something like inflation rates or economic growth. All right, so we've talked about summarizing our nominal, ordinal, interval, and ratio data with descriptive statistics. And if you're going to do this in Excel, the formulas are here. Count if, to count the number of occurrences used with nominal data. For ordinal, interval, and ratio, we might find the median. So equals median and then highlight your data. Mode, we could use with nominal, we can use with ordinal. Range is going to be the max minus the min. The mean is the average, standard deviation, ST-dev, and the geo mean is equal geo mean, and then highlight your data set. So we can find these quickly in Excel. In later videos, we'll look at how to do these in Python. Okay. Now, you could build some charts and graphs depending on what type of measurement scales you have. So if you have nominal data, pie charts, bar graphs, frequency tables. If you have ordinal data, we can do pie charts and bar graphs and frequency tables as well. For interval or ratio data, we would use graphs like histogram. In later videos, we're going to show how to build all these in Python, but for now, let's look at just how we would create these in Excel. And the key here is to make sure that the visualization tool that you have matches the measurement scale. Are you using the appropriate graph for the type of data you're trying to summarize? So let's go in, and we can see here for nominal data, we have a pie chart or a bar graph. So let's go into our data here. And so we could take our information and we could insert, and we have here a pie chart. So we can see that the majority said yes, they are a Swiftie, compared to those who said no. So we could summarize that in a pie chart. Pie charts tell us about parts of a whole. So it helps us see that percentage that is in one group versus another. And so we got that here just from insert, and then you can choose your 2D, your 3D, or the donut just creates a hole in the center of your image. People like those because it looks a bit more modern compared to the old school pie chart. Okay. We can take our information and we can create instead a bar graph. And so it can be horizontal or it can be vertical, but we could instead create that graph there. Here we're counting the number of yeses, the number of nos. The bar graph will tell us about how many people fall into different categories. If you really want to emphasize the percentage, the comparison between the two, we want it to consider the whole and how the whole breaks down, then a pie chart is better than a bar graph. If we want to simply compare how big this group is versus this group, then we want here either as a column or horizontal as a bar to help us do that comparison. And in fact, let me just go to here. So this is quite the comprehensive chart. We have videos that go through this in detail as we build these visuals in Python. You can also find this chart in my book. But you can see here parts of a whole, one variable, we want to break it down. It's nominal data. We can create a donut or a pie chart. There's also something called a tree map. You can build a tree map in Excel. It's right here. Actually, let me just pull this down a bit so you can see. All right. So pie charts, and then here we have tree maps. Okay, so you can create a tree map, and we'll show in a video how to create those tree maps in Python. You can see here that if we're doing a comparison of, and here we have our nominal data, so how many are in each group, then we can have a bar graph or a column chart. So you can see based on the measurement scale, we'll determine what type of visualization that we should do. If we're just looking in Excel here, while we're talking about them, here you saw a sunburst. We'll have a video how to build sunbursts in Python. You can build it here in Excel. And to build that sunburst, what a sunburst shows you, that's right here, what if we have two questions in our survey. One question is category, so it's nominal, and another question is nominal. And so we want to see how many people are both Swifties and in high school. Or how many people are Swifties and they are in their 40s. So we take not the actual age, 41, 42, and instead we create this category of 40s. And then this lets you look at the subset of groups within groups. So we have two variables, they're both nominal, and we can look at of the whole here, Swifties, not Swifties, how do they break down into some other characteristics? Okay, that's a sunburst. And we'll talk about how to do that in Python. If you want to do that in Excel, you're going to use it right here, but you're going to need data, not just yes, no, Swiftie, but we're going to need a second question that also is nominal data to create that. So just as you're looking at what Excel can do here, we had our column and pie charts to compare the number in different nominal groups. Then in our pie charts, bar graphs, okay, tree maps, sunburst, okay. Now, what if we have data? Let's just go back. What if we have interval or ratio data? Well, one type of visualization we can create is a histogram. So a histogram will show, so let's say we're looking at, here's the number of complaints in our business. We're going to take a measurement, maybe every day, every week, once a month, whatever that is. We've collected 10 samples here. Each time we have a number of complaints. So we actually have 15 samples here. And each day or each time we took a sample, we have the total number of complaints. We can create a histogram. A histogram will show us variability. So what is the sample with the least amount of complaints, the sample with the most, and then it bins the data. So remember, the challenge we have with interval or ratio data is we can't find a mode because the numbers don't necessarily repeat. Maybe we have 9 complaints one day, 10 the next. So what we do is we group the data together into small little ranges or bins to say, okay, well, how many fall within this group? And then that allows us to see what is more frequent. So in this case here, we're finding is that we have quite a number of complaints that are in that 10-11 and in our 6-7 group. Okay. So how do you go about creating a histogram in Excel? So here's our number of complaints. There are 2 ways to create a histogram in Excel. One is to let Excel do it for you. So newer versions of Excel now have histograms built in. It doesn't have a nice little button in any of these choices here. So instead, you likely have to go up to Insert and insert a chart and choose it here under Histogram. Okay, so I'm showing you on, this is the Mac version. On the Windows version, again, insert chart and go to histogram. Okay, so when we do that, you can see that here it is creating the bins for us. So here we're binning from 2 to 7.1. So that's going to allow for the inclusion of all the 7s. 7.1 to 12.2 is going to allow for the inclusion of the 8s and the 12s and everything in between. It's going to create the bins here as it seems appropriate. Now, the challenge we have, of course, is that we need to have small enough bins we can see variability. If we just do 2 bins, and even in this case 3 bins, it's much harder to interpret what's happening. Here, the majority is going to be less than 7 complaints, but that's quite a range between 2 and 7, right? If maybe 2, 3, 4 complaints is okay, but 6, 7 is not, we really can't see that from this. So we would want more bins to see what's happening here. And so if we went back, for example, to this visual here, you can see that these are narrower bins, and that allows us to see that there is kind of issues here and here. And we could further investigate why there is this complaints that kind of hover around here and complaints that hover around here. Okay, so how would you go about creating this in Excel? Well, to do that, separate from the, that's the only one from here, we could, instead of using just that kind of default one they have in there right now, is you could instead go to data and do data analysis. So this is the older method for creating histograms. If you don't have this little button here, you need to make sure you have the analysis tool pack. And so if you see this here on the right, make sure you've activated the analysis tool pack. If you don't have it there, you can go into your options add-ons. So you would go on your far left, choices on that top menu, and go to options add-ons and then install your analysis tool pack. Under data analysis, this is where you used to have to go to do your stats. We'll come back to some of these when we get to some basic statistical analysis, but here you'll see a histogram. To do this histogram, you're going to need an input range, which we have, but the other thing you're going to need is a bin range. So this is going to tell it where to cut those bins. So I'm going to come back to that. So we could create our bins here. And so if you instead wanted to have your bins be, maybe we'll go 2, 4, 6, 8, 10, 12. Okay. So we can see here that if I then highlight my number of complaints, do my data analysis histogram, highlight the number of complaints, highlight the bins that I've specified, and I can tell it to either put it in a new work sheet, so it'll add it as a new tab, or it can put it on the same page. You can do that. Oh, I forgot to tell it to make a graph. So if you do it this way, the only thing it's done here is that it has calculated up the totals. So it will go here and it will say, okay, how many do we have 2 up to but not including 4? How many 4 up to but not including 6? 6 to up not including 8? How many were more than 12? So here we can see those 6 up to but not including 8, 10 up to but not including 12 are going to give us the highest points. It didn't give us a graph because I, of course, dumbly didn't click on that. So let's try this again. Histogram. We have our input, we have our bin, we want our chart. So make sure you tell it to output the chart. It can do a Pareto chart. We'll actually have later videos about creating Pareto charts since we use those in analyzing the efficiency of an organization. And so you can see here is our histogram. Again, you can see this group here and this group here are the most common number of complaints, where we have 3 samples that fall into this group and 3 samples that fall into that group. So we get information on this graph in terms of variability, lowest to highest, but also what is more typical, okay? And we can see here that it is bimodal, right? Here's a peak and then there's a peak. You could choose to have wider bins, right? So instead of going in groups of 2, we could do 2, 5, 8. So this is in groups of 3, right? 11, and then maybe just go more than 11. Data analysis, histogram, here's our data. Here's our bins. And so you can see here, there are wider bins, and so then we're gonna have less on our graph. So it's how much information do you need to be able to make a decision for the organization. So in this case here, we can see that the majority of the complaints are really from that 8 to 11 group. So we can see how big of an issue complaints are. So with the histogram, you can decide that range, or you can use the default where Excel does it for you. We would use histograms to summarize both the variability as well as the more common, in this case, number of complaints. Okay, let's go back. So here we have created our histogram. There are lots more visuals. As you can see here, every single black box is a different type of visual. And so we are going to, there's the histogram here, looking at variability and distribution, where we have one variable. So right now we are just introducing different types of measurement scales, but we have videos on all of these different types of data visualizations, as well as workbooks for you to create these data visualizations in Python. Excel is adding more and more of these different types of visualizations, including, say, a box plot can be added now in Python. So if I go back to the insert, I saw it in here somewhere. We have more choices. There's the bubble one that you saw. Box and whiskers. So they're adding more and more of these visualizations. Essentially what they're doing is they're tying into Python code. So what we'll do is teach you how to build these. The key is when to use them, whether you're doing them in Excel or whether you're doing in Python. But if you want to have the most flexibility in terms of tweaking the image and the graph and automating the process for building, we'll do it in Python in later videos. If you want to do just quick and dirty, create a visualization, of course, you can do it here in Excel. The key is to know when it is appropriate to do different types of visuals. So you need to be able to identify measurement scales, which is what we're focusing on now. As we get into more of this data visualization in later videos, we'll look at the rest of this image in terms of figuring out when these different types of visualizations are relevant. So one step at a time. And before we can even do this analysis, we need to first be able to build our survey, collect the data, so then we can start to analyze it. But as we build our surveys, we need to keep in mind that how we word the questions, what type of information we collect in our descriptive research design or in our causal research design, that how we collect the data, the type of data we collect is really going to impact the type of analysis we're able to do.